simplifying radicals in complex numbers. Okay, so do y'all remember how to simplify radicals? Do y'all remember doing the radical tree? Okay, a prime tree, whatever you want to call it. Okay, so we have 80. And it's not a perfect square number, right? 81 is a perfect square number, but 80 is not. So what you're going to do is you're going to take your 80 and you're going to build your prime tree. Okay, when I do this, I like to always start with smaller numbers. Does 2 go into 80? Yes. How many times? 40. Does 2 go into 40? 20 times. 2 goes into 20 10 times. And 2 goes into 10 5 times. Now 5 is prime, so I'm done. Right? Now all of my remainders at the bottom of my tree are prime. And that's when you know when to stop. Okay? There are other ways, and I'll show you kind of in a second some little secrets. But this is our prime factor tree. So I know 2 times 2 times 2 times 2 times 5 equals 80. The reason I like to start with my smaller numbers is because then they stay on the left side and the bottom. If you kind of start doing like 4 and 40, some of your prime numbers might get lost in the middle and you might not notice them if you don't like make them stand out. So that's just why I do that. You can do it however you want. Now, what does a square root do? What does a square root do? What does it cancel? A squared, right? Well, isn't 2 times 2 the same thing as 2 squared? So if I take the square root of 2 times 2, isn't it just 2? Because it cancels the squared. It cancels the second. So anytime you have a pair, because square root cancels a squared, you just bring the 2 out. So that 2, because it's a pair, gets to go out front. Now I want you to realize this is another pair. So I'm going to take that one out as well. Now, does 5 have a pair? No, so that one stays inside. What's 2 times 2? So 4 square root of 5 is the simplified radical of square root of 80. Now, you can check this in your calculator. You'll type what was given to you, so square root of 80. And that's 8.94, whatever, it gets ugly. And you can type 4 square root of 5, and it should be the same thing, and it is. Okay? Now, one thing you have to be careful of is if you don't factor it all the way, it can still be equal. So you always need to make sure whatever's inside your factor, like that's 5, it's prime, there's no square root of 5, it's not a pretty number, so we know that we did it all the way. Okay? Any questions with that one? So let's look at number 2. Number 2 kind of has a trick to it. What goes into 288? Does 2 go into it? How many times? 144. What do y'all know about the number 144? Isn't it a perfect square? Anytime there's a perfect square, you can stop and let it be your pair. Because technically we could keep going and get 2 and 2 and 2 and 2 and 2 and 2 and 2 a billion times, but is that worth it? No, if we find that perfect square, stop, y'all. 12 times 12 is what's the pair, so that's going to go on the outside. 2 is my leftovers, and there is my answer. Okay? Does that make sense? So when you see that perfect square, you can stop. Okay, let's look at number 3. What do you notice? Huh? It's a fraction. Okay, I don't know if y'all remember, but rules of, not exponents, square roots, radicals, whatever, you can separate it. That and that are the same thing. Okay? So here's my question. Is the square root of 8 a perfect square? No. Is the square root of 25? Yeah, what does that equal? So we know we're just going to have a 5 on the bottom, but we need to figure out what 8 simplifies to. So 8, 2 goes into 8 4 times, 2 goes into 4 2 times. So we have a pair of 2's and a leftover 2. Can that simplify further? Can 2 over 5 simplify? No, so that's your answer. Okay, so now we get into imaginary numbers. Does anybody remember dealing with imaginary numbers last year in Algebra 2? You did. Okay, you might not. Well, last year was kind of a weird year, so that's kind of a bad reference. I don't know if y'all truly got into them like you normally would because COVID. But imaginary numbers. So if we start thinking about inverses, which just means opposite, quadratics, which is the U shape, right, is the inverse of square root. But do you remember square root was only half of the U? That bottom half is where the imaginary numbers are. And that's why it doesn't show up. So I'm going to show you what I mean. So technically, we have the square root, and the inverse of square root, that's quadratic. The inverse of square root was this. Do you see how it's missing that bottom piece? Do y'all remember dealing with that last year? That's where our imaginary numbers are. Because you can't technically take a square root of a negative. That's why we call them imaginary. Because if you look at the inverse, it's there. If you drew the inverse perfectly, it should be there, but it's not because they're imaginary. Okay? So that's what I want y'all to understand, where these numbers come from. We're not just making them up. Okay, so if we look at this one, we have a negative. So anytime you have a negative on the inside, you can literally just put an I out front and make it now the square root of 81. Well, what is the square root of 81? 9. So this just becomes 9i. So the only thing it does is you end up putting an I with it because you have to say that, hey, this is imaginary. Okay. Any questions? Comments, concerns? So let's look at another one. Do y'all remember doing quadratic formula? We're going to talk about it a little tiny bit today. We're not going to fully use it yet, but we will in a couple days. So when you plug in quadratic formula and simplify, it's going to kind of look like this. Okay, but we have this I, so we have our imaginary number, so we have to simplify it a little different. So let's bring that 28 over here. I'm going to go ahead and rewrite 10 plus or minus. I'm going to leave some space and put an I so I don't forget. And I'm going to separate the bottom because I see that 10 over 5 simplifies, and I don't know what's going to go there and if that's going to simplify or not. So 28, does 2 go into 28? 14 times. Does 2 go into 14? 7 times. Is 7 prime? Yeah, so we're done. So we have a pair of 2's and a 7. So this becomes 2i square root of 7. Does 10 over 5 simplify? To what? 2. Does 2 over 5 simplify? No, so this stays. But I want you to realize this is technically 2 answers. Because what do we have in the middle? A plus and a minus. So technically, you have 2 minus 2i square root of 7 over 4 and 2 plus 2i square root of 7 over 5. Any questions with that? Okay, so let's look at the next one. Now this one's a little prettier. Is this one going to be imaginary? No. okay, because there's no negative inside the radical. What is the square root of 25? So I end up getting 9 plus or minus 5 over 4. Well, this one we definitely want to simplify because it will simplify into two numbers. So, or separate, sorry. We get 9 plus 5 over 4 and 9 minus 5 over 4. Well, what's 9 plus 5? Huh? 14, and then I still have over 4. What does 14 over 4 simplify to? 7 over 2, because 2 goes into both, so when you divide both of them by 2, you get 7 over 2. Now, that doesn't simplify any further. What's 9 minus 5? And what's 4 over 4? 1. Now, technically, when you write your answers, you should write your smallest and then their biggest, and 7 over 2 is actually bigger than 1, because 2 goes into 7 3 times, so it's 3.5. Okay, cool thing is you'll be able to use your notes, so you'll never have to memorize the formula. But this one does say simplify and then write the equation from which the following came from. Okay, so let's look at that first. So I want you to know that it's negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Okay, you won't have to memorize that. One thing I want you to realize with the formula is, if you'll notice, it's just a regular b here in the middle, right? Inside the radical. But what do we notice about the b in the front? It's negative. And I want you to realize that that means opposite. So the normal b is on the inside, the opposite b is in the front. So we need to find a, b, and c, so we can plug it into our standard form so we can know where it came from. So we're still dealing with quadratic, so we know it's going to be quadratic. It's quadratic formula. Okay, so what is my a? Well, a is here and here. What do we have here and here? 1. B, which one should I look at, the normal one or the opposite one? Normal, so what is it? Negative 9. Now, what's the opposite of positive 9? So you could have looked at the beginning, just know that it's always going to be opposite of what's there. Does that make sense? Okay, because 2 negatives make a positive, so that ended up being a positive 9. Now, C is at the end, which is 20. So that means this came from ax squared, bx, and c. So now let's actually simplify it. Okay, the way you want to simplify these, just in case they're imaginary, okay, is you want to type what's inside the house first all by itself. So I'm just going to type what's inside the house, and I'm not going to include the house. Okay, so it's parentheses 9, oh, negative 9, squared, minus 4 times 1 times 20, and that equals what? 1. Okay, so I could have technically put the house on this one. 2 times 1 is 2. What is the square root of 1? 1. So this becomes 9 plus or minus 1 over 2. So 9 plus 1 over 2, 9 minus 1 over 2. What's 9 plus 1? 10. What's 10 over 2? What's 9 minus 1? What's 8 over 2? So our answers become 4 and 5. Okay, number 8. We're going to simplify. So I'm going to go ahead and separate negative 6 over negative 6 plus or minus. I know we're going to take out an I because it's negative. Bring that 84 down here, and I'm going to factor tree it. Does 2 go into 84? How many times? 42, right? 2 goes into 42 21 times. Does 2 go into 21? Does 3? How many times? Now, is everything prime? So what am I going to take out? 2, because that's my pair. And what do I put back in? 3 and 7, which makes 21. Okay, what does negative 6 divided by negative 6 give you? Can 2 over negative 6 simplify? It becomes 1/3, and I want you to realize that negative can go out front. And all it does is really flip these symbols, because a plus and negative is just minus, and minus and negative is just plus. So really you can kind of ignore the negative. So I want y'all to finish writing that out. My computer is freezing. Hold on 1 second. Okay, I want you to realize that this one did ask us to write. My computer doesn't like me. To write it in the standard form. It wants you to write the equation from which this came, but this one's a little different. Okay? So, what do you think we would do? Would it be pretty easy to find A? Yeah, because isn't this 2 times A? Well, what's negative 6 divided by 2? Negative 3. So we know that A is negative 3. Huh? Because remember, on the bottom is 2 times A. So if I divide both sides by 2, then technically I get 6 divided by negative 6 divided by 2, which is negative 3. Now, what do we know about in the front? What's in the front? Opposite of B. What's the opposite of negative 6? Positive 6. So we're most of the way there. Now, where's the only spot that we find C? Inside the house, right? And I want you to realize that is B squared minus 4 times A times C. Well, we know B is 6, minus 4 times A is negative 3, but we don't know C, right? Freeze, we don't know yet. And it needs to equal what? Negative 84. So can we solve that? Yeah, so this gives me 6 squared is 36. What's negative 4 times negative 3? 12C, because that C is still there. So what do I need to move? The 36. How do I move that 36? subtract it from both sides. So I get negative 84 minus 36, which is negative 120. Now what? Divide by negative 12. And what's my answer? So the equation it came from, what would that look like? Well, A. So negative 3x squared, positive 6x, positive 10. There's one more thing I want to show you all in the practice. Nothing huge. So if you look at the practice, I'll put that back in just a second. If you look at problems like let's do number 7. Where's that negative? On the outside. So is it going to be imaginary? No, because it's on the outside, not the inside. So don't let that confuse you. But it is a little different because we have a number out front. So let's factor our 27. What goes into 27? Does 2? Does 3? Yeah, how many times? And then 9's a perfect square with 3 and 3. So we have a 3 we can take out and a 3 we can leave in. But what's already there? A negative 10. So you're going to take that negative 10 and multiply it by whatever you're taking out. Radical of whatever you're leaving in. Well, what's negative 10 times 3? And then the radical of 3 stays. So don't let those numbers in front throw you off. Don't let a negative in front throw you off. It's not imaginary because the negative was not inside the radical.